Hi, and welcome to another DroPros video. This segment is a third of a four-part series describing the incredibly powerful EL700 color LCD display. In this video segment, we provide an in-depth review of the setup menu and the function buttons. Alright, so let's begin our third video segment on the EL700. Now, as we power up the unit, the first image that we see is the startup screen. And in the lower right, we can see the software version number, and on the lower left, we can see the language options. All right, so to continue to the main screen, I'll go ahead and tap the yellow arrow button underneath where it reads English. So here is the main screen that we would normally see in our day-to-day operations. And this brings us to our first lesson on using the EL700. The yellow arrows that surround the LCD panel are called soft keys. These are the buttons that you select to make things happen on the display. But they're not really buttons, they're just really another part of the touch-sensitive screen. So you only need to tap them instead of pushing them. Now, the advantage of this style of screen is that it's completely sealed against contaminants. So if you touch it with dirty or greasy hands, you can just wipe it down later. Now, the other item you'll work with quite a bit is the row of blue icons right above the upward-facing yellow arrows right along here. Now, these icons are also context-sensitive, meaning that what they do will constantly change based on whichever function or menu you happen to already be in. Because of this, they're called soft keys, since their value or function never remains the same. Just remember, you don't push or select the blue icons, you push the yellow arrows underneath them to select whichever particular value or function that you want. Now, the other buttons that we see on the front panel are mostly hard keys, meaning that they only perform one particular task. For example, all of the numbers on the keypad are considered to be hard keys, and the very bottom row of function buttons along here are also hard keys, meaning that they're dedicated to a specific function and never really change. And finally, the question mark circle on the lower right-hand side of the display is also considered to be a soft key. It accesses or opens the help menu. Now, because it's a soft key, this makes it extremely powerful. Basically, the help menu knows what phase or function of the display that you're already in. Let's say that you're creating an arc in the arc function menu. If you needed some help and pushed the help button, it would automatically open the help menu to the arc function chapter. But we'll explore a little bit more on that a little bit later. Now, there are a couple of tricks to remember that will make working with your EL700 a whole lot simpler. The first trick is that if you can't find what you're looking for, it's probably on a different page. So to illustrate that point, let's take a closer look at the display. Now, we're currently on the home or the main screen, but if we look to the right, just above our blue function buttons along the bottom row, we can see a small arrow pointing over to the right. And what that means is that there's another page of options or information over to the right. So to get there, all we have to do is to push or touch the right arrow button like this. So now we can see the rest of the blue function buttons that didn't have enough space on the first screen to show up. Left to right, they're the calculator function and then the setup menu, which has a picture of a hammer and a wrench. Now, right above the calculator function, we can see that there's an arrow pointing over to the left, which takes us back to our home screen. Now, in the setup mode, there are a lot of options and functions that you can program that'll make your machining a whole lot easier. And I should also mention that once you change something, it stays there permanently, even if you turn the display off. The DRO will remember exactly what you've previously programmed. In other words, you only need to make these changes once, and they'll stay in the DRO's memory forever. Alright, so to enter the setup menu, simply tap the yellow arrow button that's below the blue menu setup icon. So here we have a choice of either user setup or factory setup. We're going to be changing the user setup, and that selection is already highlighted, so we'll push the select button. And now we can see the beginning of a whole list of different options. To navigate this screen, you simply arrow up or down to select whichever option you want to take a look at. Now the first option at the top of the list is the sleep mode. Sleep mode is the built-in timer which determines when the display sleeps or hibernates if no buttons are pushed. Now to change this value, simply enter a different number on the numerical keypad. And although the display may seem to take a lower number, the minimum value is 5 and the maximum value is 120. I'll go ahead and change my sleep value to 20 minutes. The next option down is Key Beep Enable. This allows you to turn on or off the beep as you press or tap the different display buttons. Now, most users find that the beep serves as a very reassuring confirmation that they've actually selected something. But if you really wanted to make the display completely silent, this would be the place to do it. Now note that the options for this selection are along the bottom row, with the options being either off or on. The next option down is Zero Approach Beep Enable. This option either turns on or off the beeping or warning as you approach points that you've programmed in the different function modes. And just like the last parameter, we have the option along the bottom row to turn it on or off completely. The next parameter down is Zero Approach Tolerance. This setting controls when the display stops beeping at you as you approach a point. While most customers find it very helpful to have the display initially beep at them to warn them when they approach a point, they don't really want the display to continuously beep until they exactly get to that point. So to change this value, simply enter a different value on the numerical keypad. We recommend programming 10/10,000ths, as you can see here on our display. The next option, Diagnostics, allows us to perform a self-check on either the keyboard, a read head, or even the touch probe. Let's go ahead and select the keyboard option. So now, as we touch any of the keys on the display, we'll hear a confirmation beep, and the associated button is highlighted on the display in red. So to exit the keyboard diagnostics mode, press the C key twice. The next option down is the Select Axis option. Let's go ahead and select the X-axis. And here we can see an entirely new menu. Now keep in mind that we just selected the X-axis, so everything in this menu relates to the X-axis only. Now you may have already discovered that these menus simply wrap back around on top of themselves right back to the beginning. You can see on the right side of the display that as I arrow down, the blue scroll bar gives me a relative idea of where I'm at on the page. Alright, so now we're back to the top of the page, back to axis type. And I can see here that I have two choices for my axis type, either linear or angular. Now in the world of digital readouts, there are two types of scales, linear and rotary. Linear, as it sounds, is for measuring movement in a straight line, and rotary is for measuring angular or rotary movement, such as the rotation of a drive shaft. Currently, for all of our kits, all of the scales we have are linear scales. So we'll go ahead and leave this set to linear. Now the next option is scale resolution, and it's very important that this setting exactly matches the resolution of the scales. For mill kits, they currently all have 5 micron scales, so we need to make sure that this setting is set to exactly 5 microns. But notice that I don't even see a 5 micron option along the bottom row. Now, just as I stated before, when you can't find something you're looking for, it's probably on another page. And sure enough, right above the bottom row of blue buttons on the right side, we can see that there's a red arrow pointing over to the right. And sure enough, when I arrow over to the right, I can see the option that I was looking for, which in this case is 5 microns. So the next parameter is display resolution. This controls the resolution that we see on our display. The rule to remember is that the value you choose here for display resolution must be equal to or higher than the actual scale resolution. So in this case, with 5 micron scales, the smallest value I can choose is 5 microns, which will give me the best resolution possible. But let's say that we're just doing some rough work and we really don't want to see that many decimal points. So instead, let's go ahead and choose 50 microns and see what that gives us. Now, in order for this setting to be saved, there's a very specific way that we need to exit the setup menu. First, we need to arrow down until we see the Save and Exit prompt. And now we can see that we have a new icon along the bottom row of blue buttons. This icon shows a picture of a computer diskette next to a door. Selecting it will save the changes that we've made and then exit us out of this menu. All right, so now we're back to our original setup menu. Let's arrow down to the Save and Exit command at the bottom of this menu. And now we're back to our home screen. And immediately we can see that the X-axis display window only has 3 decimal places instead of the normal 4. And if we move our mill, we can see that the X-axis is counting in 2/1000ths increments, which makes sense because 5 microns is 2/10,000ths, and we just reduced the resolution of our display by a factor of 10. All right, so let's go back into the setup menu and put things back to normal. We'll arrow over to the right. We'll select the setup menu icon. We'll select user setup. We'll arrow down to select axis. We'll select the X-axis and then arrow down to display resolution. And then we'll change the display resolution option back to 5 microns. All right, so the next parameter down is axis direction. Currently, the value displays right, but I can see that along the bottom row, I can choose either left or right. And this is where you can change the scale's direction, or in other words, which way the scale counts more positive and which way the scale counts more negative. Now just remember, the setting here is completely arbitrary. Simply put, if your scale isn't counting positive or negative in the direction that you want, simply come to this parameter and change it to the opposite value, whichever that may be. Now, reference mode refers to the type of reference marks on the scale. And again, along the bottom row, I can see the available options are either single or DCR, which stands for distance coded reference. Now currently, all of our scales are single reference mark scales, so we'll go ahead and leave this option as it is. But let's say that I didn't know what DCR meant. Now, how could I find out some information on it? Exactly. Let's go ahead and use the Help menu. And remember how I mentioned before that it was context sensitive? Well, let's see exactly what I was talking about. And notice here that the Help menu is opened up explaining reference mode, which is the parameter that we're currently at in the setup menu. The opening paragraph gives us a basic explanation of reference mode, but for even more information, we can select the Enter button. And here is an even more detailed explanation of what DCR or DCRM is. Note the 2 red arrows at the top right of the display indicating that there's more information if we arrow down. Now the leftmost image along the bottom of the display is for referencing the table of contents, which would take us to the very beginning of the entire help menu. So now the arrow pointing back to the left returns us to the previous screen that we just came from. And the exit prompt, as one would expect, sends us right back to our original starting point, which was the X-axis setting menu. Now the next parameter, machine ref or machine reference, is the second step of the power out memory feature and allows us to store a user-designated ABS 0 point into memory. This allows us to recapture our exact 0 point even if the power goes out when we're machining, or in case the machine is accidentally moved with the readout powered off. The next parameter is zero approach distance. This setting controls how soon as you approach a point, the display starts to beep. To change this value, simply enter a different number on the numerical keypad. Now here is where we access the calibration menu, and the options here are either LComp or SComp, which stands for linear or segmented error compensation. Now, calibration is something that you can do, but you don't have to do, as all of our scales are individually laser calibrated at the factory. But if you truly feel the need to calibrate your scales, this would be the place to do it. Now the good news is that the calibration routine on the EL700 is extremely easy to use and much simpler to do than with traditional glass scales. Once again, if you'd like more information on this subject, simply press the context-sensitive help menu key for a more detailed explanation. All right, so let's go ahead and arrow down to the next parameter. So the next option down allows us to either apply or not apply any of our linear compensation values to the display. And finally, we get to the bottom of our X-axis setting menu, where we can choose to either save and exit or exit without saving. Since we've previously changed our display resolution back to 5 microns, we need to remember to choose the save and exit option. So this brings us right back to the main user setup mode. Now, if we needed to change our other scales parameters, such as direction, we could do that right now by simply selecting the other axes. But I think we're good to go, so let's go ahead and continue down to the next parameter. So the next option is serial communication. This deals with the baud rate, parity, and the number of data and stop bits. But unless you have a completely customized setup, the default value should work fine for you. So let's go ahead and continue down to the next option. So this brings us to the next item, Recall OEM Settings. This option would be used to reset the display to the original equipment manufacturer or OEM settings. Now, this would be very helpful if you were a teacher of a shop class with a bunch of students, and at the end of the day, if a display was acting strangely, as if perhaps someone had tried to reprogram it, well, you could just simply reset the display back to the original OEM settings. But for most of us, this isn't something we would ever have to change, so we'll go ahead and continue on. So the next option is Machine Model. And because the EL700 is built with an LCD screen, it can be easily used for either a mill or a lathe and still be properly labeled. Let's go ahead and take a look. We'll go ahead and select the lathe option and then arrow down and choose Save and Exit. And immediately the display has been configured for a lathe. Now, just as we would expect, the axis windows are now properly labeled. The cross slide is the X-axis, the carriage is the Z-axis, and the top slider compound would be the Z-prime axis. But let's go ahead and change this back to the mill display. So to do that, I'll first need to go back into the setup menu. We'll arrow over to the right, we'll select the setup menu icon, we'll select user setup, arrow down to machine model, Then we'll choose Mill, arrow down to Save and Exit, and then select the Save and Exit command. All right, so that was a pretty thorough explanation of the setup menu. So next, let's go ahead and take a look at the hard keys on the lower part of our display. First, let's take a look at the inch and millimeter button. If we look at the top of our display, we can see that we're currently in inch mode. But if we push the inch millimeter button, the top of the display now reads millimeter, meaning that the display is showing distance or position in millimeters. The other way to tell the display is reading in millimeters is that all of the display windows now have 3 decimal points instead of 4. All right, so simple enough. I'll go back to inch mode. And now all my axes are reading in 4 decimal places, and the top left of the display now reads inch. All right, so let's now look at the button to the left of the inch millimeter button. This button switches the display from reading in absolute mode to incremental mode. Now, normally we always want to work in absolute mode. And if we look at the top of the display, we can see that there are 2 arrows that are parallel or right next to each other. This is the icon for absolute mode. Think of it this way. In absolute mode, every point gets its 0 point from the same reference point, just as the 2 arrows both start from the same point. Now, if we push the absolute incremental button, we can see a change at the top of the display. The icon now shows 2 arrows, but they no longer both start from the same position. Instead, they're lined up together incrementally, one after the other. And think of the incremental mode as a sort of a scratch pad. As long as we're in incremental mode, we can zero out the display as much as we want and still retain our original ABS 0 point. But remember, most of the time you want to stay in absolute mode. But I'm not sure that my explanation really explains it well enough, so let's go ahead and do a quick example. So first, let's put the mill back to absolute mode. Next, I've set up a ruler and a pointer on my mill, and I've moved the mill so that the pointer is over the beginning of the ruler. All right, so let's say that I'm cutting a part and it needs to be 3 inches long. So to do that, I'll move my mill 3 inches down the ruler. So now we'll assume that I'm at the end of my part and I've cut it to be 3 inches long. But the plans also say that I need to drill a hole 1 inch from the end. So let's first do that in ABS mode and see what happens. So to begin, I'll zero out my x-axis and then move backwards or to the left 1 inch. So now my x-axis reads -1 inch, so I'm exactly where I want to be. But the ruler reads 2 inches. So in other words, I've lost my original ABS 0 point, which was at the beginning of the ruler at 0. So was there a better way to do this and not lose my ABS 0 point, or in this example, the beginning of the ruler? Well, yes, and what we should have used was incremental mode for the second move. So let's try it again, only this time we'll use the incremental mode to make the second move. All right, so let's move the mill back to the beginning of the ruler. Then I'll zero out the x-axis window. So again, I'll move 3 inches down the ruler. But this time, I'll now switch to the incremental mode. And I can see in the top left of my display that my arrows no longer originate from the same point, but instead are incrementally next to each other. This tells me that I'm now in incremental mode. So now I'll zero out the x-axis and then move backwards 1 inch, just like before. And just like before, my x-axis currently reads -1 inch. But now let's go ahead and switch back to the absolute mode. And what do you know? Both the ruler and the display both show 2 inches. So even though we switched over to the incremental mode, and even though we moved the table and then zeroed out the x-axis, the absolute mode was still keeping track of our true position along the ruler. The point of this exercise is to show you that absolute mode will always track your true position even if you swap over to the incremental mode and even if you zero out an axis, as long as you do it while you're in the incremental mode. Again, you can think of incremental mode as a type of scratch pad that you can always zero out. Alright, so the next button just to the right of inch millimeter is for power out memory. Power out or power off memory allows the user to restore their absolute 0 point if the mill is accidentally moved with the power to the DRO switched off. If we push the button, we can see 2 different options: homing and machine reference. Now, homing is the first of a 3-step process in which we can locate the reference marks along our scale. Machine reference is the 3rd and final step where we reestablish or capture our original 0 point after it's been lost due to either a power failure or an operator error. Now, you may recall that step 2 of this process was found in the user setup menu as machine ref in the axis setting menu. Alright, so an easy way to escape out of this mode without an exit button is to push the C key. Alright, so the next button over starts the distance to go function. This function allows us to program a set distance to count down to without altering or losing our absolute 0 point. But before I start this function, note that the x-axis display window reads exactly 2 inches. Alright, so let's go ahead and push the distance to go button. And note that the top of the display now reads preset distance, so we need to select which axis we want to perform the function on. So I'll go ahead and select the x-axis window. And then we'll enter the distance that we want to count down to. In this case, we'll go 1 inch followed by the enter button. Next, we'll move our mill to count down to 0. And now that we've counted down to 0, we simply push the exit button. And now, note how our x-axis window now reads exactly 3 inches. Remember from before we started this function that we started at 2 inches. So in other words, we never lost our ABS 0 point. Our display was always keeping track of our absolute position the whole time, even when we were in a completely different function. Alright, so the next function is the SDM function. The SDM function allows the user to program up to 199 individual waypoints into system memory. So to start the SDM function, simply push the SDM function button. And the first screen that we see here is the SDM job menu. This is where the SDM jobs are saved. Now, assuming this is the first time that you've been in the SDM job menu, there won't be any listed. So to start programming SDM waypoints, we first select the setup sheet or the piece of paper. Now to store a point, we'd simply move our mill until we physically get to the point that we want to store into memory. But in this video, we're really just trying to explore the buttons, not exactly running or explaining all of the functions. So let's go ahead and exit the SDM mode by pressing the exit button or the door icon. And that returns us to the job menu, so we'll exit through the door again. And here we are back in our home screen. Next, let's explore the blue buttons along the bottom of the screen. The first button is the function button. And here we can find a long list of different functions. Now the first is bolt hole, and within this function there are actually three different functions: bolt hole circle, bolt hole arc, and a custom bolt hole function where you can choose exactly which angles you'd like your points to be located on. The next function down is the line hole function, which plots a string of equally spaced holes along a single line. The grid function creates a square or rectangular shape pattern of equally spaced individual holes. Frame is similar to grid, except it only plots points around the outside perimeter of a square or rectangle, hence the name frame. Arc contouring allows the user to define an arc of holes starting and ending at a specific angle. The R function is a simpler version of arc contouring, which allows the user to select from 8 predefined 90-degree arcs. Now, the purpose of the pocket function is to cut out or remove a square or rectangular shaped pocket of material. This function differs from grid in that its purpose is to remove all of the material between the points rather than create a pattern of equally spaced holes. The slot function is nearly identical to the pocket function, except instead of removing a square or rectangular shaped pocket, it removes a single line or slot of material. Polar coordinates changes the display from displaying points in the traditional Cartesian coordinate system, i.e. x and y distance, to the polar coordinate system, whereby points are designated instead by the distance and angle from a designated point. Zero approach allows the user to turn on or off the beep associated with approaching an absolute or ABS zero point. The job timer allows the user to display a timer on the front of the display showing how much time has elapsed on a particular job. Here you can reset the timer, designate an hourly rate, or turn it off completely. And finally, the last option is a shrinkage factor. This function would be used by mold makers to compensate for a fixed rate of shrinkage when producing parts from a mold. Alright, so that completes the function mode, so let's continue across the rest of the function buttons. Now the zero button simply allows us to quickly zero out any of our axes. When we press it, we can see that all of our axis windows now have a zero displayed next to them. And if we press any of the axis window buttons, the axes reset or zeros out in one easy step. Now if we push set, the windows go back to the normal display, and now if we press an axis key, instead of zeroing out, it allows us to input a value. This is called direct entry, which allows us to directly input any value to any of our axes. Now the next mode is a set probe mode. This is for initializing a touch probe to work with our display. If I start the setup sheet, the first thing I'll do is to name my probe, followed by setting the diameter, length, RPM, and speed of my probe. Finally, I can edit any of my previously saved touch probes and also exit back to the main screen with the touch probe turned on or off. Now the half function allows the user to find the center point of any axis. Simply push the half function key followed by the axis of your choice. And the final key on the right side is to start the touch probe function. The probe mode opens up a wealth of options to the EL700 user. Here, the operator can automatically capture any axes, measure step height, outside width, inside width, single or multiple angles, or even find the exact center point of a circle. Alright, so to get to the next page of function buttons, we push the right arrow key. So here on the next page of blue buttons, we first see the calculator function. Not only can we perform a wide variety of calculations here, but we can also transfer the results of our calculations directly to any axis. Alright, so that wraps up the third of our 4-part video series on the EL700 color LCD display. In this video, I've explained the setup menu and what each of the buttons on the front of the display does. It's easy to use, I've shown you how to do it, and now you can do it too.